just did one question.
Why do you have a big container full of fish? It's empty, which is just tempting me to get more.
I don't know, guys. Miss Boyd. Okay, here we go. Listen up. Where's Aiden? He didn't get. He was never. How could he play any sports?
When he had all. Oh wait, huh?
Yes.
He kind of sat out most of the time. You want to talk about him, though? I did my homework.
Cool. I'll collect here in a second. All right, everybody look at the board.
It's cool.
This is the what we're going to be doing. We will. You heard me yesterday saying this. We think that field day is Wednesday. Obviously, we won't have our class here. We're going to finish up quadratics. Something's off here. This should not say. We're not doing another day of that. Move 12:5 here, so that makes the chapter 10. Yeah. Okay. So just move that. I'm not sure why I made that mistake. Unless I left off. There might be a number I left off here. I don't know. Well, I'll have it better for Monday.
It says
yeah, but it should just say 1, 2, 3. It shouldn't have 2 3s. That's weird. I don't know. Maybe I left off. There's a 12-6 or something. I'll see. Regardless, we're going to finish up chapter 12. We'll take a test at some point. It could be this Tuesday. It could be this Monday. If I made a mistake, it's probably Monday, not Tuesday. And then we'll jump right into semester final review, and then we're done with the year.
Why that many reviews? When do we have that?
So this is going to be from January until May. All the material from January to May, that's what the test is on. So that includes third quarter and fourth quarter. Every quarter, there's 3 chapters. So 3 chapters from third quarter, 3 chapters from fourth quarter. That's 6 total chapters of material. We're finishing up chapter 12. Right, so from chapters 7 through 12 is what the semester final is going to be on. I need more than 1 day to cover 6 chapters for a review. In fact, I need 3 days. As always, Lily, Tristan didn't pay any attention last year, so he probably didn't even notice this. She's the only one?
She's yours, so mean to me.
That I taught pre-algebra to?
No,
Sophia? Yeah. I couldn't remember. So they saw 2 semester finals from, you've seen 1. You didn't take your semester final last year. No. I mean, you literally you didn't even show up to take your final.
Yeah, I remember.
All right. But if you remember from last year, and okay, let's be honest, most of us probably didn't put our best effort because of that quarantine, but it's a little bit different this year. So the semester final will be a multiple choice test. It's going to be long. We got an hour and a half to take a test. I'm using all that hour and a half. I will not put a ridiculous number, but it's usually somewhere around 50-ish type questions for the test. They will all be multiple choice. So some people do really well on a multiple choice test. Other people, because it's so easy, just to, I don't know what the answer is, I'll just pick B and move on. Other people don't put enough effort into it. But a lot of people love multiple choice tests, especially on a math test. There's only 4 answers and one of them is the answer. So even if you don't know how to do it, you can kind of take a good guess and figure it out. What's up?
When do we take our final?
So we are letting the seniors, although we don't have seniors this year, we have sophomores. We usually let the seniors pick their schedule. So the seniors are going to pick the schedule of semester finals. So they literally they look at their schedule like, ooh, I got, an anatomy and physiology final and I have an English final. I don't want to take both those on the same day. So they I don't know what they're going to pick, but they're doing it this week. We'll put the schedule. They're supposed to pick today or something like that. We'll tell you on Monday what they picked. But it's going to be, if I were to do the calendar right here would be that Monday. It's going to be 2 tests there, 2 tests, 2 tests, 1 test. Friday is just for makeup. Friday is not, if you take all your tests, you're not coming to school on Friday. On this Thursday, it's only 1 test, so take that 1 test, go home type thing. On these, you're going to take 2 tests, go home. As you remember how it worked in December? Yeah. You show up, you go to student advisement for 30 minutes or so. That's just to hopefully get ready for the first test. Then you go take your test. It's about an hour and a half long. Then you go back to student advisement. You have time to do a little bit more studying, and you go take that second one, and that's the end of the day. So hour and a half for each one. So it's 3 hours of testing with, another hour or so of sitting in a student advisement class. But we break it up into 2 parts.
But why do a chapter 12 test if it's not fun? You know?
That is a good point. I mean, literally, it's like a week later, I test you on literally. I mean, I agree. That's seems crazy, right? How about if instead of putting the total number of questions for chapter 12, I put half the number? I'll just say this: most people, Nathan, that would be thinking the other way. Give me more questions on chapter 12 because I literally just did it. So that's the stuff that's fresh in my mind, right? Okay. We are going to finish what we did yesterday. It was okay, class, but we didn't really, the end there, we kind of did that really quick, and I saw a couple eyes roll in the back of your head. So if you look in front of you, it's the same stuff. I'll give you a worksheet. The worksheet will be different for today. I'm going to give you the same stuff as yesterday. Do it really quick until we get to that chart, and then we'll spend some time on the chart. So quick review from yesterday. We were graphing and talking about what does a graph of a quadratic look like. We call this the parent function because the only thing here is just an x and a square. There's no x squared plus 6x minus 1 or anything like that. It's just plain old x squared. We call this the parent function. All the other functions that we could make with an x squared called the daughter functions. Okay. We said that we don't have a nice, pretty, y equals mx plus b for these. We have to use the table of pain. We pick a whole bunch of numbers. The numbers I suggested were -2, -1, 0, 1, and 2. And I said, just plug those numbers in. -2 squared is 4, -1 squared is 1, 0 squared is 0, and then you get a 1 and a 4. Okay. So, and then we graph that. We graph it makes this shape. And we talked briefly about all quadratics make parabolas. They will always look like this. Now they can be skinny, they can be wide, they can be flipped over. Right, but they all make this shape right here. Algebra 2, half of the book is about that shape right there. Okay, half of the book. Okay. Okay, so that's the parent function for quadratics. We explored, and you guys did well on this. We explored what would happen if we put a number in front of the x. And since that a is being multiplied by x squared, what we found out, for instance, 2x squared. That's one of the ones you had last night for homework, by the way. What we found out was that, well, if you plug the numbers in, you get those numbers. -2 squared is 4, 4 times 2 is 8. 1 squared is 1, 1 times 2 is 2. We get those numbers. And what we really found out, and there's the picture of it, what we really found out is we compare the parent function to the daughter function, right? It's the daughter, it's the parent. We compare the parent to the daughter. Well, it literally is you take all the numbers of your parent function, you multiply by 2, and you're done. I guess what I was trying to inform you, if you caught on, is that all of your homework last night was just simply take these numbers, just take whatever number was there, multiply that, and you're done. If you had noticed that last night, then last night homework was about 5 minutes worth of work, right? If you didn't notice, well, it's still okay. You just simply plug the numbers in and do your thing. Now, the interesting thing about quadratics is you just can't, for linear, you can pick any numbers you want, literally any numbers you want for x. For quadratics, if we only picked -2, -3, -4, we would have gotten a graph that looked like from here to here, it wouldn't have looked like a smiley face. The fact that it goes down and goes back up is, well, you got to pick the numbers where that happens. And that's a really challenging thing to do with quadratics when you graph them by hand. With graphing calculator, it's no big deal. But picking the right numbers for quadratics, we haven't even talked about how you do that. Picking the right numbers can be a challenge. Okay, so last night for homework, you had 8 of these. So all you really had to do was take the parent function and whatever that number is, multiply these numbers by a graph. You're done. Okay. We explored that as the number increases, the parabola gets skinnier and skinnier. I'm taking these numbers and multiplying by 3. 12, 3, 0, 3, 12. Gets skinnier and skinnier as these numbers get bigger and bigger. We explored that as the numbers get smaller, right? Instead of it going up, it goes down. Then the parabola gets wider and wider and wider and wider. Reason being is you're not multiplying by half, you're really dividing by 2. 4 divided by 2 is 2, a half, 0, a half, 2. And when we graph that, it gets wider. Okay. Lastly, we said negative numbers take the graph and it just flips it over the x-axis. It takes the normal graph of 3x squared and simply flips it. So you take 3, you multiply it by this, attach a negative, and it flips it over the x-axis. It takes the normal 3x squared and just flips it. We call this, well, we don't call it I can say frowny face. All right, these are all those graphs just showing you. The solid one in red here is the parent function, x squared. You want to make it skinnier, make that a bigger. You want to make it wider, make it a decimal fraction. You want to flip it, make it negative. All right, that was more of an exploration than something that you truly have to memorize or whatever. I will on the test though simply give you a quadratic. You have to graph it, right? You got to make a table of pain, pick the numbers -2, -1, 0, 1, and 2. Do the table of pain, plot the points. I won't give you 12 of those on a test. I'll give you one of them. The second thing is we name the parts. What did we name this part right here? Called it the vertex. And the interesting thing about the vertex is it kind of splits the parabola, the smiley face here, into halves, right? You draw a line through the vertex. You draw a line through the vertex, call that the axis of symmetry. It's basically, if you were folding a piece of paper, this side would fold onto that side, okay? Those were the two parts, the axis of symmetry and the vertex. I'm doing this really quickly. Lastly, we gave some names to how it opens. Notice that this parabola right here opens in an upward direction, like it's pointed up. We say it's U-shaped, right? We call this one V-shaped, right? I'm sorry, we call this one U-shaped. We call this upside down U-shaped, okay? By the way, this is the equation. So it's the parent function, x squared, shifted up 1, right? That just moves it up 1. This is the parent function shifted down 1 with a negative in front of it. Remember, a negative flips it. If I move it down 1, it would look like this. There were two parts that we described right here. It's how it opens, whether it opens facing to the sky or facing to the ground, right? We call that one open up or concave up. And we call this one open down or concave down. And then lastly, where we left off, and this is the hardest part for some kids to wrap their heads around. We're going to be talking about the y values. I'm going to stay on the red line. I'm going to talk about the y value, not the x values, but the y values of the line itself. The y values go increase, 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 increase until it gets to this number. And then they decrease, 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 decrease. So if we talk about, and it's opposite for that one over here. The y values decrease, 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 decrease until it gets to the vertex, and then they increase. So the vertex is the, I don't know, the point of where things change, right? So if we think about the y values, right, the minimums for both of them, like the smallest y value you get to on a concave up is at the vertex. That's the smallest y value. Smallest y value right here is negative or positive 1, sorry. But the smallest y value here is, well, this, I left off the arrows. This goes on all the way down to negative infinity. So the minimum for this one is a 1. The minimum for this one, where does it go? It goes all the way down to negative infinity. You got a minimum, you got a maximum. For a concave up, the maximum is, well, it shoots off to positive infinity. But the maximum for the concave down is the vertex, whatever that number is right there, negative 1. That's where we left off, okay? Questions? Okay. Tonight for homework, they're going to ask you to do these things right here. They're going to ask you, well, they're going to ask you, where is the vertex? Where is the vertex? Where's the vertex? -1. It's at, well, it's right here, right? So they're asking you the coordinates of it. That's 0, 1, somebody said, right? So the vertex is at 0, 1. And they're going to ask you, what is the minimum? What's the maximum? Well, the minimum, remember, we're talking about y values here. We're saying if I stay on the red line, what's the smallest y value I get to? It will always be inside the vertex, right? Either the min or the max will be somewhere inside the vertex. So the smallest number I get to, y value, I'm at y value 10, I'm at y value 6, y value 4, y value 2, y value 1. So the minimum is 1. So this one is a what is the minimum? Well, the minimum, and remember it's y values, is 1, but what's the maximum? Infinity. There you go. Easy, right? What's the vertex? Careful, it goes XY, not YX. Goes 0, -1. Can you see that? Where is the vertex? It's right there. It's 0, -1. My dot's a little bit off. What's the minimum? -infinity. What's the maximum? Questions? That's pretty simple. Okay. So on your own right now, this is like we kind of did this really quick yesterday. So grab your pencils, grab your pens. Don't do the domain and range yet. That's the last thing we'll talk about, then we're done. Write the vertex and write the min and the max. It doesn't say the min or the max. Write the min and the max for all 6 of these.
All right, right now, would you rather have our class like this or this?
Like this.
I just realized how small it is right now.
Well, it's not that it's the number of people. It's the number of people that are annoying.
Like me? You want me out of here?
Have I told you this year you've been annoying? Did I tell you last year you were annoying?
Yeah.
Yes, I did. Have I ever told you this year you've been annoying?
No.
So what's different?
I don't know.
The first time I've ever actually wanted to get sports team.
It's not good food though.
Still, it's food.
Answer. You're about 10 minutes away from getting food.
Not good food.
Okay, I'm confused on this.
Not enough
So
either.
with the
Where, put it down on the vertex. What's that point? X comma Y. X comma Y. So where's the X axis? That's the Y. So where are you at on that number line? And then the Y? 2. I'm sorry, the max. So like the biggest number, the Y value, like this.
Don't go smiling.
The minimum one will.
He doesn't.
So I apologize. There should be arrows.
Can we have that?
Can you have what?
That blue bag.
No. There should be arrows on these,
It's been
Piper.
sitting there all week.
I know, because every day I'm like, don't forget to bring it home. Don't forget to bring it home. I've forgotten to bring it home for 4 days in a row.
We'll eat it.
All right. How do you know there's food in there?
We know that you haven't eaten it.
What?
We just know.
Oh, you did?
Because when I'm
That was
hungry,
this
I can
class?
tell where food is, and that's food right there.
Yeah,
Well, you're lucky the mice didn't eat it. Probably they have.
I will eat the mice then. 'Cause that's also food.
Oh, that's
You don't get much food from mice. You've already done? Done?
Oh, are you
You don't think I know that?
Both. You're both looking up here like, hey, can you talk faster?
I kind of want the worksheet.
You okay?
Ah.
Yeah, but the vertex is at 0. I'm like literally physically, where is the vertex? Put it down on the vertex. So what's the coordinates of that point right there? 0. So the minimum is where? What would be the smallest Y
I
value?
mean, I'm just so drained that I just want to cry because it just takes so much time to do. You know what I mean?
Smallest number.
You get annoyed because you can't go
I have like none.
so
Put
much.
on a mustache.
Where's the line?
All with those.
Touch the line. No,
You need a good description.
curve. The thing is graph.
And it's
So
just
what's the
like,
smallest
yeah,
Y?
I could like be
Where's Y?
where's the
Yeah.
you need like a straight. I go to like
Continues all the way down. Continues all the way down. Smallest Y.
camouflage
What's the biggest Y?
and I'm like, it's not those are
Correct. So where's this one? Now,
first,
yeah.
and then they're gonna see
So infinity is not the minimum.
shot back.
So the max would be
They do your long form. Okay.
You got it. So the ones that go concave up, you're going to have a max and an infinity always. The min will be wherever the vertex is. And it's opposite for the concave.
I don't do long.
Brandy, we already got it done?
No, they don't.
Lily, you got it done?
Serious.
You boys have it done?
Yeah.
Okay. Nathan, first one, give me the vertex and the min and the max.
0.
Okay.
Yeah, but it's a point. The vertex is a point.
I know that I wasn't done.
Okay, 0. It was a long pause. 0 what?
0, 4.
Perfect. Min and max.
4.
Is the min or the max?
4 is the max.
He said
Four is
I
the
said
min.
Min or max?
Negative and
4.
And remember what we're talking about is the line
Where's the
itself,
max?
it goes up and it stops going up and it goes back down, right? So it reaches a maximum at that point right there, which by the way is the vertex.
You just said
The,
max.
the min and the max could be different whether it's concave up or concave down. For the concave down ones, it only reaches a maximum. The minimum is going to be negative infinity. So the minimum is negative infinity, the max is 4. All right, Caden, this one.
I want.
I should do that.
Vertex is 0, 0. No, it's not.
No.
It's not 0, 0.
Listen. Okay. I did it wrong.
My name's not Linda.
I said listen.
Listen, Linda.
You didn't get it.
Wait.
So,
Such an old joke.
maximum is 0.
I'm good with the min and the max. What did you say the vertex was?
I said 0, 0, but it's 3, negative 3.
There you go.
There you go. Negative 3, 0, and then you got the min and the max correct.
Ow, ow.
All right. Chris, this one right here.
Oh,
What's the vertex?
like 2.5.
It's 2.
Oh.
So 2 what?
2's the 0, 0.
Not 0, 2.
2, 0.
The vertex is right here.
Yeah.
That's not 2, 0.
2. It's 2.
The 2 is the x, right? What's the y value?
0.
Uno.
Oh, wow. I'm an idiot. Yeah.
Yeah, you are.
Oh my God.
What's the answer?
1, 2. No, 2, 1.
2, 1. Okay.
Wow. That's how
Look it up.
What is the minimum that that red line touches? It's a red curve, it's more precise.
Come on.
What's the smallest y value that that red curve touches? What is it? 1. What's the maximum it touches? Okay, we got that right. Julie, you got this one right here?
It's like when you're brain.
Hey, guys, speak. I can't hear. Vertex is at. It's reversed. So 0, negative 2. And the min and the max are? Perfect. Negative 2 is the max, though, and negative infinity is the min. Okay? It does. I mean, the fact that you knew that those both numbers I'm pretty happy with. But if it literally says what's the min and you put negative 2, technically that would be wrong. All right, Tristan. Vertex.
Oh, wait, that's easy. Negative 3.
It's a ordered pair. It's a point.
Oh, 0, negative 3.
No.
Something like that.
Chris, help him out. Vertex.
Like negative 2, 3.
You got that wrong as well,
It's like,
too.
Okay, say if like.
Negative 3.
You talking?
I said negative 3.
It's not 2.
Negative 2.
So negative 3, negative 2.
When I say negative, I go for both of them.
All right. Min and the max.
The minimum.
What is the largest number that the curve touches?
Negative 1.
Negative 2.
No, it's
What's the smallest number that the curve touches? Like, I'm on the curve, right? I'm touching negative 6 right now, y value. Hey, I'm touching negative 8. Hey, I'm touching negative 10. What's the smallest number it touches? Knowing that there are arrows right here.
negative 10.
There are arrows.
Maybe.
Oh,
Negative infinity. I took way too long. All right. Ari, you got the last one. Vertex, min, max.
Get it.
No.
I don't think it's negative.
Wait, which one?
The very last one.
Positive
3,
3, positive.
4, and then min, the max.
4 and
Say again.
4 and infinity.
Perfect. 4 is the min, infinity is the max. Okay. Hey, no jokes. There are a lot of mistakes there, but do we have this or not?
We got this.
Because on the scale of difficulty, this is the easy part, right? This isn't the hard part.
Oh, we're done with the worksheets.
The hard part is coming on Monday. All right. But this is the easy part. The last thing is this thing called domain and range. You just got to wrap your head around it. If you can wrap your head around this, eventually, it took us 6 examples, but you can wrap your head around the vertex and the min, the max, you can wrap your head around domain and range. It's just a different weird thing. You just got to be able to wrap your head around. Okay, so the hardest thing is to remember which word goes with which value. I'm a sequential person. Like when I think of life, when I want to bring order to something, I think about a sequence. Let's put things in order. Like I was the kid, when I had my blocks, I would always put little, okay, the round ones go over here, the square ones go over here, the triangles go, I would put things in order. And for me, whenever I say, well, try to teach someone how do you remember this, I always think everyone thinks like me. I'm like, whoa, this is the way you should think. I know that doesn't work with everyone, but I will try. If you are a sequential person like me, and I just say, put them alphabetical, you're going to have 2 words, domain and range. They either refer to the X or the Y values. And for me, it makes perfect sense. Well, they're alphabetical. X comes before Y. Domain comes before the word range alphabetically. X comes before Y. D comes before R. I don't know if that helps, but that's how I remember it. Okay. The hardest thing for high school students when they first start doing this is we'll ask for the domain and you'll give me the range, or I'll ask for the range and you'll give me the domain. So you have to be, either on a resource card or you got to have it memorized, or whatever method you have of remembering those 2. The domain means what X values you're allowed to use. The range means what Y values occur in the function itself. In other words, when you do the math, what do you get out of it? Okay, so we will be giving you a quadratic function and we will ask you what's the domain and the range. Step number 1 is you graph this sucker. Tonight for homework, Merry Christmas, I've graphed them all for you. Okay. It isn't that big of a deal because guess what you did last night for homework? This is the one that you graphed last night for homework. So even though I probably should make you graph it again for the practice, you can if you want, but I'm saying it's not that, we're going to assume that you can graph. So here is this function graphed. I'm going to ask you for this function, which is the graph of it, what is the domain and the range? Okay, so here's what it's really asking. It's saying, if you did a table of values, you with me? The domain says, what numbers can I write here? So what numbers can I plug into X? Is there any number that I can't plug in? Like for instance, watch this. If the X was on the bottom and this was the function, could I put a 0 here? Like, are you allowed to put a 0 if X is in the denominator? No. On your calculator, you can do 1 divided by 0? Yeah. No, you can't. Your calculator says, no, I will not do that.
It'll say error.
It'll say error. So it's not that this is always the answer that I'm about to show you, because some functions you're not allowed to put some numbers in. Same thing with the square root of X. I can't put a negative number. So sometimes the domain, what you're allowed to write in your table of pain, if you do your table of pain on your calculator to this function right here, and you scroll up, eventually it'll say error, 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 error for any negative number, because you're not allowed to do it. The nice thing about quadratic functions, you can take the square of anything. You can square a negative number. You can square a decimal number. You can even square 0. So what numbers are we allowed for quadratics to put in for the domain? What numbers can I plug in? Any number. Okay. Tonight for homework, when it says, literally it's on your sheet in front of you, what's the domain? It's all real numbers. Mathematicians a long time ago got tired of writing all real numbers, and they came up with a symbol for it. This is the symbol for it. So it's an R with a slash on it, an extra thing on the vertical part. You can write either all real numbers or that symbol right there. Range is not the same answer. Here's what the range answers. What Y values does this red line touch? Remember, there's arrows. Does the line ever touch -2?
No.
Does it touch -1?
So it's a positive.
Does it touch 0?
Yes.
Does it touch 1?
Yes.
So it touches all the numbers from,
Positive.
well, 0 is not positive or negative.
Well, better.
Brandy, the answer is?
Y is greater than or equal to 0?
Yeah.
y is greater than or equal to 0. The numbers that the line touches are 0 to infinity. If you wanted to write that in words, because you couldn't remember which way the inequality should face, all the numbers greater than 0 to include 0. Yeah.
Wouldn't, if it's flipped upside down, you would just flip the.
You would flip the inequality.
Sorry, points is 0 and 11.
You would just flip this inequality. If it was a, if it had a, if this was a negative 2x squared, then it would be y is less than or equal to 0.
Yeah.
Yeah, absolutely. Yes. For quadratic functions, yes. Quadratic functions are something that says something x squared. Notice if it was 1 over x, if this was y is equal to 1 over x, this is all real numbers except 0. Like I can plug in negative numbers, I can plug in fractions, I can plug in decimals, I just can't plug in a 0. So algebra 2, by the way. In algebra 2, they're going to say, what's the domain of this one? You're going to say all real numbers except 0. We've seen that a couple times this year. Remember we found out what are the numbers it can't be? All right, here we go again. What's the domain? Everybody should get this now. What's the domain? All real numbers, right? Either that or that symbol. The range is going to be what y values does it touch? So what y values am I touching? Am I touching positive 2? Am I touching 1? Am I touching 0? What's the first y value I touch?
-1.
And all the numbers smaller than -1. So how do you write that? Now equals less than or equal to -1. That's not that bad. Oh, by the way, this is all the homework now. What you see in front of you right here is all the homework. I think we're out of time, right?
Yeah. It already rang, isn't that?
Yeah, but it's the first one is not our lunch. It's the, is it 2 minutes after the second one? Right? I think it's 2 minutes after the second bell rings. Lunch starts at 12:05.
What time is it now?
We got 6 minutes. We got plenty of time. All right.
Honestly, should you give us the paper?
Well, how about we just jump to this bit? Okay. So let's do this real quick. We'll start with Caden.
Yes.
What's the domain? Upper left. What's the range? It's on your sheet of paper.
Y is less than or equal to.
Perfect. Chris, what's the domain? For any quadratic function. The domain is the x values that you're allowed to plug in.
I'll run.
Hey, you're not going to learn a darn thing.
What they said.
Yeah, but why is what they said true? I don't know what that function is. Well, actually, I do. That's x minus, no, x plus 3 quantity squared with a negative in front of it. That's that function right there. What numbers am I not allowed to plug in for x on this one? Like what number can you not add 3 and then square it? So you're saying if I put a -1, I'm not allowed to do that? I can't do -1 plus 3 and square that? Is there any number that I could not plug in for x?
Probably.
The answer is no. I can do any number. You can add 3 to any number, literally any number, and then you can square that number. For all, are you listening this time? This is why they immediately yell out the answer. For any, these are all quadratics, they're all parabolas. For every single domain, the answer will always be all real numbers. That's what that R means, all real numbers.
Okay.
What's the range? What y values does this red line touch? Not the min and the max, what y values does it touch?
Wow, the -3.
It does touch -3. What else does it touch?
The -4, -2.
What else does it touch?
-6, -8.
So what numbers does it touch? We got 2 minutes. What? Does it touch positive 2?
No, it's negative.
And one extra number. That is true, by the way. It does touch all the negative numbers. What else does it touch? That's a negative number, so it touches it. What's that number right there? No, that's the x value. Range is the y values. 0. That's y value right here, 0. So y is less than or equal to 0. Done. Sophia, this one. Domain. Domain.
Oh, domain R.
Range.
I'm going to do the range too. I did it all.
I know.
Y is greater than or equal to 1.
You got it. Julie, domain. Range. Got softer as you went on. It's like I hear everything. No, I don't hear a darn thing. I heard y is less than or equal to, and then I didn't hear the number. You got it. Piper, domain. Domain.
Oh, all real numbers.
Okay, range.
Y is greater than less than negative.
Greater than would mean up here.
Yeah.
Okay, so
Red line's nowhere up there.
so that's less than negative.
Unless I'm not seeing a negative 3. Negative 3 is right here.
Yeah, but we're talking about.
What's this number?
Negative 2. Oh.
So y is
Less than.
or equal to. Okay. First and last one, we're done. Domain.
All real numbers.
Range.
Y is greater than
Or equal to.
equal to negative R4.
And you're done. All right. We got this?
Yeah.
All right. Homework is right here. Look at me. I'm giving you some nasty, nasty, nasty quadratics. They've already been graphed for you. There's nothing to worry about. The graph is already in front of you.
Reading in here.
All you have to all you have to do is the domain, the range, the vertex, and the min and the max.
So are you pulling?
I am in a second. One for you. You get a car. You get a car. You get a car. I got it.
We've got a motorcycle today.
I'll get some. Give me a second. Let me get
All
past
right.
it.
I have them there.
Nice. That's a sack. It's heavy now. Homework?
Okay.
And it hurt me a while for you. That's pretty good. If you really pushed hard, you could literally be done before even school ends. You gotta get through. I mean, you don't have to, but you could be done. Now listen. Julie, don't do that.
What?
It's not like all of a sudden I don't notice this or
Don't notice what?
that you literally just write random things on your homework.
I know you didn't just.
Yeah, but I'm saying
even hard.
it's
I told her to do the work.
it's one thing if I was the English teacher you're turning in math homework to, but if you turn to the math teacher, you turn in homework, it's like we don't stop being the math teachers. We know what it's supposed to look like. And that's not what it's supposed to look like. Just show up to class and do the work. You're plenty smart. You can get all of this done. Well, come on. Well, you didn't do any of this. Not a single one that's right.
Well, no, none of them.
I know, because you literally just wrote a U on every answer.
That's the best way to do it.
It is literally on the board. Look at the board.
No, I know it.
Oh, got it.
Hello,
Hey, how are you?
I'm well. How about you?
I am good. I'm well too.
Good. Good, good.
And I'm better than well because it's Friday.
Yes, yes, I do like that. I like that too.
Nathan, I got your homework. I got your homework that was on your desk. What else? Oh, I'm sorry, Caden. I was like, why is Caden looking at me like I'm crazy? Well, how about your brother? What does he think? Are all the kids named with a K? Do you have sisters? Catherine. Catherine?
No.
Kennedy. Okay. What's the they just like K? Your parents? Is it?
It was the same thing with their siblings. They weren't all like spelled with K's.
Yeah.
They had, like, a K sound in them. So
Oh, okay.
it was pretty funny to go
All right.
along with it.
I had a friend, he named all his kids with R's. He had 4 boys, Riley, Ricker, Randall, and what was the 4th kid's name?
Richard.
No, it wasn't Richard. No,
Have one.
Riley, Ricker, Randolph, and
What are you doing?
Robert. What?
That said Dublin is good.
Very bad. I don't have that much.
I love being a vegetarian. That meat was so good.
No. Somebody at a party that I went to, and they said, I don't eat, I'm sitting there, they got offered pepperoni pizza, and they said, no, I'm a vegan, and they eat their cheese pizza. And I'm like, do you mean vegetarian? Not vegan?
What did Rylan play?
Aiden, Mullion, Jack.
I knew.
They all played basketball.
Thank you. Are they going to come back during lunch or no?
I have no idea.
If they do come back, this is the worksheet for tonight.
I'm not gonna give it to them just so they all do something.
Well-
I screened off Sierra's name, she owes me.
There probably a couple more going to be here to pick it up, so I'm fully anticipating. It is on Teams. Does anybody want me to leave this on or no?
No.
All right.
Can we look at cows eating bananas? Okay, I'll leave this in now.
There's got to be more interesting animals than cows eating bananas.
There are giraffes.
I wanna see a fish eating
Do
banana.
Ramen, can we watch ramen?
Ramen?